Hey guys, it is Obi here. We're going to start talking about our HVAC system today. So, HVAC stands for heating, ventilation, and air conditioning. Um, okay, so just a little bit of review. So, the HVAC system is going to contain really three main components. It's going to be the ventilation system, which consists of everything required to distribute conditioned air throughout the occupant compartment. That we talked about last week. It's also going to talk about the heating system, which consists of everything that is used to transfer heat from the engine to the interior. We also talked about a good bit of that last week. And then finally, the air conditioning system, which consists of everything required to lower the temperature in the occupant compartment. So that is what we're going to start talking about now. So specifically today, we're going to start talking about freons. So there are multiple different kinds of freons, but we are specifically today going to talk about R12. So R12 is an old freon, was banned in 1996, and it is a CFC that has a global warming potential of 10,680 and is very harmful to the ozone. So we might understand this one, and I imagine the rest of them were like, what the heck is going on? So let's just do a little bit of a refresher today on why it's harmful to the ozone, and then we're going to understand what a global warming potential actually is. So just a quick refresher. What's happening? The ultraviolet rays from the sun get blocked in the ozone layer, and the ozone layer is between 7 and 30 miles above the Earth. So the floor of the Earth is here, and we go 7 miles above to 30, and that's where we find the ozone layer. Okay, so the ozone layer is an O3 molecule, and what it's going to do is it's actually going to block the sun. Okay, so it's not blocking out the entire sun. We're not saying no sun for you down on Earth, but what it is going to do is it's going to take the ultraviolet rays and it is going to basically reflect those back to the atmosphere. Think of it like putting sunscreen on. So the sunscreen will still allow you to get a tan, but it doesn't allow the sunlight to be so intense that it burns you, okay? Or at least not as fast. So the ozone layer is really kind of important to us. We kind of rely on it. Now, what happens as we begin to deplete that, and I want to make sure everybody understands, as the ozone layer gets depleted, it's not that we just get a big hole in it. It's that there's physically an area that this is thinner. Okay, so it's not as thick, and the ozone is not very tightly packed in here. You might have an ozone molecule here, and then another one here, and another one over here. So what happens is the sunlight has to travel through that entire area, and that is how eventually it'll hit one. Okay. So what we found is that the CFCs, the chlorofluorocarbons, R12, came up to the atmosphere, got broke down by the sun, and then the chlorine molecules were connecting with the ozone layer and basically breaking it down. That's what we really need to know, okay? So that's been a pretty big issue. Now, if you guys have ever been into a bigger city and you've heard them talk about the heavy ground level ozone, so if you've ever been in a big city when they talk about those days where it's a breathing hazard because there's a heavy ground level ozone, that is the same thing as the ozone layer in the upper atmosphere. We call it smog when it's at the ground, and what it does is it kind of blocks that sun, and it makes it look like a foggy day generally. Okay? So if you're trying to visualize it, that's kind of what's going on. Okay, so now the next thing I want to talk about is the global warming potential. So global warming potential is a measurement of how much heat a component will trap in the atmosphere. It is calculated with many different factors, such as how much pollution is produced to make it, is probably one really good example, and how much damage it'll do to the atmosphere after it's actually produced, or the environment, I guess is the best way to put that. So it is compared to carbon dioxide. That would be the standard for global warming potential. CO2 has a standard of 1, okay? And then to make sure we all understand, from this point on, we're going to refer to it as GWP because global warming potential is just long. So anytime you see GWP, that's what it means, is global warming potential. So we know that carbon dioxide has a global warming potential of 1. R12 has a global warming potential of 10,680. That is a huge increase, right? Okay, so we'll look through the rest of them, the other freons as we go, and we'll find out that this number is really, really high. So obviously, we figured out that it's harmful to the ozone. It's kind of harmful to produce also. A lot of emissions go along with production of R12. So due to that, production of R12 was banned in 1996. Now that does not mean that you cannot buy it. It is entirely legal to buy. Excuse me, let me turn my phone off. It is entirely legal to buy, but it is illegal to produce, to manufacture. So what that means is there is no more supply of R12. So originally R12 was really cheap, but because our supply is limited and our demand continued to stay the same for a while, costs of R12 skyrocketed. To the point now that it's actually fairly difficult to find. Most people don't have R12. If you do, there's some money in it. However, it's not nearly in demand now as it used to be. We can actually retrofit R12 systems to R134A, and R134A is much cheaper, so a lot of people do that. However, if you're trying to have like a period correct car, or some people, R12 does tend to cool just a little bit better, and some people just want to stay with that, you're probably going to have to pony up the cash to buy it. Because we're never going to have any more. So production was banned in 96, and you can buy it, but you can't get it. So basically that means that we kind of stopped using R12 on production vehicles after 1996. Okay? And one final thing I didn't actually say, and I want to make sure everybody realizes, R12 is a chlorofluorocarbon, which means it is a CFC, chlorofluorocarbon. This is different than the other freons that we're going to use. So you should probably remember that R12 is a CFC. Okay? All right. I'll talk to you guys later. Obi out.